let's look at predicting products. Predicting products is not that difficult as long as you have a basic understanding of how ions come together and you know how to correctly make ionic compounds. You're only going to have to be able to predict products for synthesis, single replacement, and double replacement reactions. So let's start off by looking at synthesis reactions. Synthesis reactions basically just come down to being able to create the ionic compound. So step number one, again, is to find the charges of those individual ions. Step number two is to cross those charges and make them into subscripts for the opposing element. So let's take those individually. If we have our example Al plus O2, we know that Al is a +3 charge and O2 is a 2- charge from the periodic table. Step number two, to cross those charges, remember we're going to disregard current subscripts. So the 2 on oxygen is not going to play any role in the product. So when we cross the 3 and the 2, our product is going to be Al2O3. Something to keep in mind that I just mentioned is that subscripts never cross the arrow unless they're part of a polyatomic ion. So that subscript of 2 on oxygen is not going to cross the arrow and has no bearing on the product whatsoever. Single replacement reactions, remember for these we have to look at the individual element to determine what is going to switch places. So Al2O3 plus Li, we're going to label those as either metals or nonmetals. So metal is aluminum, nonmetal is oxygen, and lithium is the other metal. So because lithium is by itself and it's a metal, they're going to switch places. So now we're going to find the charges and cross the charges. We know that lithium and oxygen are going to come together. So when we cross those charges and make the compound, we have Li2O, and then aluminum is just left by itself. If we switched lithium with chlorine, now the individual element is a nonmetal. So instead of the 2 metals switching places, now the 2 nonmetals are going to switch places. So aluminum, instead of being paired with oxygen, is now going to be paired with chlorine, and your products are AlCl3 plus O2. Now you may be asking yourself, how do we know that that oxygen gets a subscript of 2? The answer is that it's because it's a diatomic element. Diatomic elements are always attached to something in nature, so they have to be attached to themselves if they're by themselves. The rest of the diatomic elements include bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. If you make a word out of those, it would be Brinkelhoff. It's an easy way to remember them. And remember, just if any of these elements are by themselves, they have to have a subscript of 2. They basically follow the buddy system, whereas if they're not attached to something, they're going to be with one another. If we move on to double replacement reactions, remember the phrase inside with inside and outside with outside to help you remember which elements combine with one another. So if we look at our example of MgO plus LiF, the 2 inside elements, Li and O, are going to come together, and the 2 outside elements, Mg and F, are going to come together. It's almost like the FOIL method in math. So we have Mg and F coming together, and we have Li and O coming together. So we're going to write all of those charges. Magnesium is a +2, fluorine is a -1, and we're going to cross those charges to make our first product. So our first product is going to be MgF2, magnesium fluoride. To make the second product, we still have those Li plus and O2 minus, so we're going to cross those charges, and we're going to get Li2O as our final product. So the 2 products for this reaction are MgF2 and Li2O. So remember the 4 basic keys to successful product prediction. Step number 1, or key number 1, is to remember how to make ionic compounds. Find those charges and cross those charges. Number 2 is to understand which ions need to be put together in a compound. So if the nonmetal is by itself, you're going to switch it with the other nonmetal. And if the metal is by itself, you're going to switch it with the other metal. Number 3 is that subscripts never cross the arrow unless they're part of a polyatomic ion. And 4 is that Brinkelhoff elements need a subscript of 2 whenever by themselves.